Hello everyone. Welcome to the solution of LeetCode problem 951 named flip equivalent binary trees. In this problem, we are given two binary trees and we have to determine whether these two trees is flip equivalent or not. So here, a binary tree X is flip equivalent to a binary tree Y if and only if we can make X equal to Y after some number of flip operation. And here, if both of them are flip equivalent, we have to return true. Otherwise, we have to return false. Now let's consider the first example. Here, the root is 1, which has two children, 2 and 3. 2 has two children, 4 and 5. 5 has two children, 7 and 8. And 3 has one children, which is 6. And for this node or tree 2, the root is 1, which has two children, 3 and 2. 3 has one children, 6. 2 has two children, 4 and 5. And 5 has two children, 8 and 7. So here we can see that from the first tree, we can get the second tree after some number of flip operation. So here we can see that both of them are flip equivalent. Anyways, the practical simulation I will be explaining in the next section. Now let's move on to the algorithm. I hope you understood the problem statement very well. Now here, to understand the algorithm, we have taken these examples given in the problem statement. So here, in the flip equivalent, we have to run a recursive algorithm and we will start the recursion from the root node. And here, the basic definition is we have to check whether the root is equal or not. Here we can see that the root is equal. So we can say this both of the tree or this both of the root is flip equivalent. Now we have to check whether its left subtree is equivalent to its left subtree. Now the algorithm is pretty simple. Here there can be two conditions. For any of the cases, the root value can be equal to the secondary root value. Or we can say that the root value of the first tree can be equal to the root value of the second tree. If it is, we can say that we do not need any of the flip operation. Suppose for the first root node 1. So here we can see that this 1 is exactly equal to this 1. So we can say that both of them are equal. So we do not need any of the flip operation. Now here, the second intuition is that if the value are not equal, suppose here for the first tree, the left subtree root value is 2. For the second tree, the left subtree root value is 3. So both of them are not equal. If it is the case, we have to convert the first tree's left subtree with the second tree's right subtree. So here we can see that this 2 is exactly equal to these 2. So both of them are equal. So far so good. These 1 are the equal. Now for the left subtree, we have the value 4. And for the left subtree here, we have the value 4. So both of them are equal. So we do not need any of the flip here. Similarly, for the right subtree, the 5 is equal to this 5. So we do not need any of the flip here. Now, for the left subtree, we have 7. And for the left subtree, we have 8. Both of them are not equal. So we have to convert the left subtree with the right subtree. So this 7 is exactly equal to this 7. So it is solved. Similarly, for the right subtree 8, we have to compare it with the left subtree. So this 8 is exactly equal to this 8. So we can say that this left subtree and this right subtree are flip equivalent. But wait, we have to check whether this full tree is flip equivalent or not. So here, from the root 1, we will be to the node 3. So here, these 3, let's erase this node here. Now we can say that this right subtree 3 is not equal to this value 2. So we have to compare these 3 or this right subtree with this left subtree. And both of them are equal, 3 and 3. So, okay. Now, for these 3, its left subtree is 6. But these 3's left subtree is null. So both of them are not equal. So we have to compare this 6 with its right subtree of another tree. So this 6 is equal to this 6. So far so good. Now for the right subtree, it is null. And similarly, this null is exactly equal to this null. So finally, you can say that overall this tree will return the value true. And here, if in any of the iteration, it can be proven that the tree is not flip equivalent, we can simply return false. I hope you understood the algorithm. Now let's move on to the code. Now here, we are given a function named flip equivalent. We are given two trees S and T. Now here it can be possible that both of the tree is or both of the root is null, so we have to return true. Otherwise, if any of the root is null and another root is not null, or the value presented in the root is not equal, we can return false. Otherwise, we have to perform the flip and no flip operation. So here, suppose till now, the value of the S and the value of the T is equal. And so we have to check, or we can say that till now, the value presented in the root is equal. So we have to compare both of the roots left and right subtree. So for the first, we can check by doing no flip operation. So here, for the no flip operation, we can recursively call the function in both of the left subtree of the these two tree. Similarly, both of the right subtree of these two tree. After that, we can perform the flip operation. So, or we can recursively call the left subtree in the first tree and right subtree on the second tree, and right subtree on the first tree and left subtree on the second tree. Finally, if this function returns true, then we can say that both of the tree are flip equivalent, otherwise it is not flip equivalent. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.